Hello kids, welcome back to Pre-Algebra. This is now our fourth lecture that we have. I'm using Pre-Algebra for Christian Schools by Bob Jones University Press. You can use any pre-algebra text that you have. The concepts are going to be the same. Maybe a slightly different order, but everything that I teach on these videos is applicable across the board to any pre-algebra class that you're taking. So today we're going to be working about using addition and subtraction to solve equations. But first, a couple of lame jokes. Okay? Why did the horse cross the road? Well, to get to his neighborhood. And why did the turkey cross the road? To show the armadillo that it could be done. And let me see, what is the other lame one? Oh, this is so ancient. What did one bug say to the other bug after it flew into the windshield? Bet you don't have the guts to try that again. So, we are now on, in Bob Jones' text, page 14, solving equations using addition and subtraction. And what we're doing now is not necessarily something that you can't just look at and figure out on your own, but what we're working on is learning a concept so that when you get to something a little bit more difficult, you'll know the procedure, you'll know the method to use so that you can solve the answer. If I wrote this equation up here, and I said x plus 3 is equal to 4, I would expect every single one of you who's watching this video to say, well, obviously 1 plus 3 is equal to 4, so therefore, even though I don't know anything about algebra, I know that this x thing here, that if I put a 1 in place of that, I end up with a true statement. Well, yes, so you solve that equation, but you really didn't solve it by using principles and properties of addition and subtraction. We have to get this methodology down so that when you have something that's a little bit more challenging to do, you know exactly what to do. So that's what we're going to do. We're beginning to actually get some more building blocks of algebra today. And we're talking about the connection that there is, the relation that there is between addition and subtraction. And we say that addition and subtraction can sort of undo each other, or it's like zipping and unzipping a coat. Let's say that we start with 12. And what happens if we add 8 to it? Well, 12 plus 8 is 20. Let's subtract 8 from 20, and what do we get? We end up with 12. If we have 3 plus 2, we get 5. We subtract 2 from that again, and we get 3. And what you see here, the number that we started with initially, the 12 in the first equation, and the 3 in the second equation, when we sequentially, which means in sequence, one after another, when we sequentially add and then subtract the same number, it has no difference. It's like you've got your jacket on, it's unzipped, you zip it up, you unzip it, your jacket is still unzipped. If you start with your jacket zipped up, you unzip it, you zip it again. You're doing two different operations, but the net result is the same. So what we say here, this principle that you're seeing here, is that addition and subtraction are inverse operations. This is what I said again. One more example. Algebra, pre-algebra, geometry, biology, all of these a little bit upper level classes that you're starting to take. A whole lot of it has to do with vocabulary. In biology, if you don't know what mitochondria are, you can't tell me anything about mitochondria. In chemistry, if you don't know what stoichiometric equations are, you can't tell me anything about it. Pre-algebra, what's an inverse operation? All inverse operations are they're operations that undo each other. They have a net change of 0. You add and subtract something here, But we didn't change the final value. The starting value and the final value are the same. We have a starting value of 3. We added and subtracted something, didn't change it. The ending result is the same as the initial, so they're inverse operations. They undo one another. Addition and subtraction are inverses. In just a couple of days, you're going to see that multiplication and division are also inverses. But today, all you need to learn is that addition and subtraction are inverse operations. Subtraction. Sometimes I can spell and talk at the same time. Sometimes I can't. Okay. Inverse operations. So what does that mean for us with algebra? Well, let me just go ahead and show you. I actually introduced the concept of a seesaw or a balanced scale last time. Let's see, if you've got, here's my little T that my seesaw is sitting on. And we've got it balanced. Let's say that we have a block over here that weighs 60 pounds. And if you don't know it, the number sound, the number symbol, it's the pounds. Also, that represents pounds. That's why when you're pressing things on your phone, it says press pound. That little tic-tac-toe thing means pounds. You have 60 pounds on one end, and you have 60 pounds on the other end. Your equation's balanced. Your seesaw is balanced. Your equation is balanced. And don't be picking on me about the fact that I don't have it exactly in the middle. You're right, I don't. But we're going to say that that's our equal sign. 60 pounds is the same as 60 pounds. Well, what happens if we put on 10 pounds? A 10-pound triangle. We add 10 pounds to this left-hand side. We now have 70 pounds on one side, 60 pounds on the other. It's out of balance. It's uneven. It's not equal. What do we have to do to make this weigh the same? Well, one thing we can do is we can add 10 pounds onto the other side. Now, we have 70 pounds on both sides. Different number, 70 and 70, but they're still equal. They're still in balance. We have added 10 pounds, and we now have, on either side, 70 pounds. So now we have 70 pounds on the left, and we have 70 pounds on the right. What happens if, here's my rectangle, what happens if we take this little chunk here, take out a chunk of that, it's 10 pounds. We've subtracted it. So we now have 60 pounds over here. And we have 70 pounds over here. I drew this where it's balanced. Well, it's not balanced because 60 pounds is heavier than 70. How can we bring it back into balance? Same way that we did over here. We can take our corner chunk out. That's 10 pounds. We can take 10 pounds out. And we now have 60 pounds on one side of the equation, 60 pounds on the other side of the equation, and it's balanced again. What did we do first to get to the 70? We added 10 pounds to both sides of the equation. What did we do to get back to 60 pounds? We took a bite out of both sides. We took a 10-pound chunk out of each of these boxes, which brought it down to where we have 60 pounds again on both sides of the equation. So that's what we're doing. If you add the same thing to both sides of the equation, like we added 10 pounds on both sides of our seesaw, it stayed in balance. If we subtract the same thing from both sides of the equation, we subtracted 10 from both sides of the equation, it remained in balance. And that's what we're talking about when we're using properties of addition and subtraction to solve equations. So let's go ahead and use an actual example here of what we're doing. Let me check my text, and I'll answer that one later. Okay, we have addition and subtraction properties of equality. Now, what I just did with these pictures that I drew up here, I illustrated properties of equality to you. It says you're starting out with 60 pounds. You add 10 pounds to one side, you add 10 pounds to the other side, and it's still equal. You take 10 pounds off, then you take 10 pounds off of the other side, and it's still equal. So now let's look and see what that looks like algebraically. This says for all numbers A, B, and C, for all numbers A, B, and C, if A equals B, then A plus C is equal to B plus C, and A minus C is equal to B minus C. That looks like a mouthful of alphabet soup because you're not used to talking about math looking like this. But all that really means is, let's say we have 7 is equal to 7. Here, A and B are the same number. 7 is equal to 7. If we're going to add a value for C, A plus C, 7 plus 2, that makes sense, doesn't it? You add the same value to both sides of the equation, it remains in balance. Same thing here. Let's say that we have 7 minus 3. We've subtracted the same value from both sides of the equation, and it's still the same. So that's what you need to learn from section 1.4, is that as long as you add something, the same something, to both sides of the equation, it's all right. That's how you solve it. As long as you subtract something from both sides of the equation, that's all right, and that's how you solve that as well. So let's look at example number 1. X minus 23 is equal to 98. And see what we should be doing. X minus 23 is equal to 98. What do we start with? We started with some number. We don't know what that some number is, but remember our seesaw that we had over here? We had 70 pounds. What did we do? Remember, we subtracted, took a bite out of that. We took 10 pounds out of it to get 60. What have we done here? Well, we've subtracted 23 pounds, or 23. We've subtracted 23 from this. What's the inverse operation? What undoes it? The opposite of subtraction is addition. So look what we can do. X minus 23. I'm just writing a little bit of space in here while I go get my other marker. X minus 23 plus 23. Now, what did I say with our properties of addition, subtraction, and that balance? As long as I add the same value to both sides of the equation is still balanced. I add 23 to the left side of the equation. I add 23 to the right side of the equation. It's in balance. If I start with some number and I subtract 23 to it, and I add 23 to it, doesn't change the value of it. Let's say that I say 24 minus 23. What's 24 minus 23? It's 1. And then I'm going to add 23 to it again. The value doesn't change. When you use inverse operations properly, you add and subtract the same number, your initial value doesn't change. So what you have here, x minus 23 plus 23, all we have on the left-hand side of the equation is x is equal to 98 plus 23. What's 98 plus 23? Well, it is 121. What you just did was solve the equation for x using the fact that addition is the inverse operation to subtraction. The inverse of subtraction is addition. You added 23 to the left-hand side of the equation. You add 23 to the right-hand side of the equation. The equation remains in balance. You have x is equal to 98 plus 23. If you can't do it in your head, that's fine. 98 plus 23. 3 and 8 is 11. Carry 1. 121. Do it by hand. Do it in your head. Do not use a calculator. No calculators are allowed at this point. Much later in Algebra 2, I'll let you do some calculators. Not now. And when I said Algebra 2, I meant pre-algebra. Much later in pre-algebra, there'll be a time that I allow you to use calculators. For now, you're solidifying and cementing and just burning into your brain all of your addition, subtraction, multiplication, and division. So, that's how you solve that one. Well, let's look at a different one. What if we have x plus 17 is equal to 43? Well, and it's going to say, your problem is going to say, solve. Solve x plus 17 is equal to 43. What they want you to do is tell me what that value is for x. Now maybe you can look at this and say that it's 26. I would expect a lot of you to be able to do that. Well, I don't want you to write me an answer. What you've got to be able to do is learn the method of using inverses to solve equations. So your next step is going to be x. What did I do to x? I added 17. What is the inverse of addition? It's subtraction. So I'm going to subtract the very same amount that I added, minus 17 is equal to 43. Is that the end? No, no, no. Why not? Because your seesaw is out of balance. You only subtracted 17 from one side of the equation. You have to subtract it from both sides of the equation. X plus 17 minus 17 is x, is equal to 43 minus 7 is 26. That's your solution, and that's all there is that you need to do. Now, let's see. What do we do if we have a similar problem, but it says solve it and check the solution? So we'll completely change this, solve, and check the solution. We're going to have y minus 21 is equal to 74. Solve part 1 and check part 2. Half of your problem is finding the answer. The other half of your problem is showing me that it's correct. Solve. How do you solve this? You look for the variable and see what's been done to it. Have you added something? Have you subtracted something? We've subtracted 21. Then you think, what is the inverse of subtraction? What operation undoes what has happened here? Addition. You add that same value, 74. You are not done here because you have to perform the same operation on both sides of the equation. So you add 21 to both sides of the equation, and you have y is equal to 94. And if you know how to add, it's not 94, but it is 95. Sorry about that, y'all. Am I completed with the problem? Solve and check the solution. Solve. Where's my check? This is what you do. You write check. Remember, what did you do to evaluate an algebraic expression? You took the value that they give you for the variable and substituted in. So we're going to write our original problem. Y minus 21 is equal to 74. Do we have a value given to us for y? Yeah, we just said that it was 95. So we're going to substitute in 95 minus 21. And we're going to say, is that equal to 74? Then we're going to do our subtraction by hand, right along the side if you'd like to. 95 minus 21 is 74. 74 is equal to 74. Check means that you end up with a true equation. Now, when I did this, when I wrote incorrectly before, I wrote a 94. What would have happened if we put 94? Well, hopefully you would have gone and caught it when you checked it, because you put in the 94 and say 94 minus 21. I did something wrong. This is the value of taking the time to be slow, methodical, go back and check your work, because obviously 73 is not equal to 74, which means that you had a mistake up here somewhere. So that's what we're learning. That's what we're going to be practicing on section 1.4, solving equations using addition and subtraction. We're remembering that subtraction and addition are inverse operations, and they undo one another. We're also remembering that equations remain in balance as long as you do the same thing on both sides of the equation. If we add 15 to the left side, we add 15 to the right side of the equation, and it remains in balance. I will see y'all next time.